great. So let me get started a little bit about me. I'm the practice director of the application modernization team at 3Cloud. I've been working in the Microsoft stack all of my professional career. Got my start working in Visual C++ and Visual Basic way back when. Moved into the .NET framework when that was released. Had a brief stint in SharePoint that I don't talk about much, but mostly been doing web technologies since then. For the past 6 years, I've been focused just on the Azure space. So at 3Cloud, my team and I are responsible for guiding clients through their digital transformation journey and helping them modernize their application workloads. So one of the things that we help folks out with is Azure Integration Services. So agenda for this meeting or for this webinar, we're going to talk a little bit about what is Azure Integration Services. And then I want to dig in a little deeper and talk about each part of that. A demo, of course, to give everybody a sense of how easy this stuff can be. And then we will finish it up with a little question and answer. I'm sure Crystal mentioned this already, but if we do have any questions, please enter those into the questions pane and I will try to pause from time to time and answer those. So let's get started. What is Azure Integration Services? So here's a high-level explanation of it. It's Microsoft's cloud offering. It consists of a whole set of serverless technologies, which we'll talk about here, that essentially allow companies to integrate their disconnected business systems. So you've got a system over here doing some work, you've got a system over here doing some work. How do we get those to talk to each other, share data, move things back and forth in enterprise level fashion? So before we dig into a little bit more on integration services, I want to level set on what serverless means. So we had one of the poll questions. It looks like we've got maybe some understanding of what serverless is, but I want to walk through that a little bit right now. So let's talk about the first aspect of serverless. It doesn't mean there are no servers. This isn't magic out there that your code runs. It just means servers you don't need to care about. So essentially, when you're running something that is serverless, you're leveraging compute, right? So processor, RAM, all of that Microsoft, in this case, is responsible for maintaining. So you don't have to spin up a VM, install an operating system, get that patched, all that fun stuff. It's just RAM and processor that you can just leverage. The next thing to talk about when it comes to serverless is event-driven scale. So with serverless, you can scale the workloads effortlessly, either manually or automatically. So for example, if all of a sudden one of your websites starts to get a ton of traffic, you don't need to call up the infrastructure guy at 2 in the morning and say, give me some more servers, add them to the load balancer. The serverless stuff will scale for you automatically. So that's a really nice feature, makes everybody sleep a little better at night. It also handles high availability really well. So if, for example, you've got an instance of something that's failing, it'll just kill it and spin up another one or two of them. A lot easier to deal with those sorts of things. The last thing to mention is sub-second billing. So from a costing perspective, serverless is by far the best place to go with your workloads. So you only pay for the time that the code is executing. For example, let's say you've got, an integration that runs 1 time an hour for 10 seconds. That's it. So essentially that's 240 seconds worth of time. That's all you pay for. You're paying for about 4 minutes worth of server time a day instead of a whole VM all day, all month, right? And from a sub-second perspective, let's say an integration takes 600 milliseconds. Great, right? Or 500 milliseconds. Stack 2 of those up, you pay for 1 second, right? You didn't pay for any more than you need. So really, really great capabilities here. And in a lot of cases with the serverless offerings, Microsoft will even give you a certain X number of executions for free. So I forget Azure Functions, it's a ridiculous amount, 400,000 or something like that, of like execution time seconds that you get for free each month, just for using it. And then you start paying really pennies on the dollar after that. All right, let's move into benefits of serverless. Okay, great, Nick, we understand all of that stuff. Why else would I use them? So you can ship much faster. So with serverless, there's a much shorter setup time, which allows you to ship your code faster. You don't need to worry about things like high availability and scaling, like I mentioned. It's all built in, right? Just do the thing that you want to do and it'll work. Reduced DevOps. So because you don't need to worry about all the stuff, high availability, scaling, you don't need to worry about servers or any of that. Your DevOps is just take the code out of the repo, put it in the serverless component. That's it. That's all you need to worry about. And then, of course, what that means is that you're allowed to really focus on the business logic. So if you're a developer like myself, right? Hey, I've got code, it works. Okay, great. Now I need a virtual machine. I need to install IIS, and how do I want IIS installed? And okay, I need to worry about how am I going to get the traffic into that particular server, and how many of the servers do I need? And it's like, oh, I thought I was just writing code, and now I'm becoming all of these other things, right? Just focus on the business logic, and it makes things go a lot better. So that is essentially what serverless is. So let's talk a little bit about Azure Integration Services. So Azure Integration Services is not a piece of software you install. It's not something you download like Microsoft Office, right, or something like that. It is actually a term used for a set of serverless components that we group together to enable this integration between systems. So when you look up Azure Integration Services in the Microsoft documentation, you'll see them mention 4 things. You'll see them mention API management, logic apps, service bus, and event grid. And those are great, and those we definitely use. But through the stuff that all the integration projects we've done, we also know that Azure Functions are one of the workhorses of Azure Integration Services, along with Event Hub, if you have a lot of data that needs to come through. So we'll dig into each one of these components individually and give you a sense of kind of where they fit in this Azure Integration Services platform. The first one I'm going to talk about are function apps. So I mentioned this before, they're the workhorse of Azure Integration Services. So developers can write code in any of these supported languages, right? C#, JavaScript, Python, and Microsoft is adding new languages all the time. And then really, the code gets executed when something happens. So what's that something, right? And so that something is down here in the available triggers. So do you want it to run, like I said, once an hour, once a minute, once a second, right? Do you want to be triggered every time a message gets dropped into an Azure Service Bus queue, which is what we'll show in the demo? Do I want an HTTP webhook? Do I essentially want every time an HTTP request hits a URL, I want to start something? Right, those are the different initiators from an Azure function standpoint. So a couple of examples here of just high-level pieces. One is, let's say a file gets added to blob storage, which is Azure's file storage component. An Azure function wakes up and says, oh, there's a file, what should I do? I'm going to go ahead and transform this CSV into data, and then maybe a Power BI chart drives off of that information. Second example here, maybe every 15 minutes I've got some data that comes in, maybe from an outside system, maybe from sort of Internet of Things piece. I want to clean that up to make sure I don't have a bunch of bad data. I don't want to do that all the time. I don't want to create SQL, like SQL jobs, because that makes me not able to move into more of a SQL PaaS part. I want to be able to do this in a very cloud native way. I'm going to kick this thing off every 15 minutes, connect to a SQL database, and clean the data. Third example that I'm going to go through here is sort of an IoT thing again, or Internet of Things. We've got lots of devices dumping data into Azure. That all goes into an event hub, which is something that I discussed before. And we want the function to wake up and transform that from maybe unstructured JSON data into structured data that goes into a SQL database. So functions can be used here. Another good point about mentioning about this example is that this is where scale really comes into play. So if you've got this particular integration set up like this, and you've maybe got a pilot, and you've got 10 devices out in the field spitting in, I don't know, 100 records a minute or something, not a big deal. One instance of that function can maybe handle it. Okay, now we roll this out in the real world, and we have tens of thousands of devices dropping, tens of thousands, if not millions of records. Your function is going to automatically scale to handle that, right? There's an algorithm in the background that Microsoft has. Hey, look, my wait time on this one function is now getting above 3 seconds. Give me another one, give me another one, give me another one. And it'll scale magically, right, automatically, to be able to handle that workload without you thinking about how many web servers do I need and how much RAM do I need to give them, that sort of thing. Moving on to one of the next major components in almost any integration that we do is Service Bus. So if you've heard of things like MSMQ or RabbitMQ, this is essentially one of that, but it's in the cloud. So you don't need to install or run with anything. Essentially two different types of items inside of a service bus. One is a queue and one is a topic. So queue is first in, first out and guaranteed one-time delivery. So you know that that message is only going to be consumed by one thing. A topic is a pub sub model. So we have one message that wants to get dropped in, and maybe I've got two different integrations. One needs to send an email to say, hey, I've got this file, and another integration needs to go and pick up that file and do some processing. Right? In that case, you would use a topic, drop one message in, and both of the subscribers or the people consuming those messages off the back would get it. So anytime you have to do messaging between systems, and I'll show that again, show that here today, we use Service Bus. It's very robust, one of the oldest services that has been around in Azure, and it's very, very, very stable. The next component in Azure Integration Services is API management. So this is essentially a front end for all of your APIs that you could be creating as part of your integration. So this goes as a front end. You can either connect existing APIs, or if you've got a logic app or a webhook function that wants to be fronted, you would put it behind API management. And then API management allows you to group all your APIs into things like products and subscriptions, and then handles all of the cross-cutting concerns like authentication, throttling, rate limiting, caching, those sorts of things that people like myself as a developer, I don't want to worry about. I just want to write the code and have somebody else deal with all of that. With an API management, also you get a developer portal. So if you've got Swagger documentation or Open API documentation, developers can go to this developer portal and see all the APIs that are available, see examples how to do it. And again, if you've got the Swagger part, then you can run examples and all of that stuff. And it's fully extensible. So we've helped a lot of folks take that developer portal and customize it from a look and feel perspective and a functionality perspective, so that there's a one-stop shop for all of the APIs, either for integrations that you're building or really for any APIs that you're building as a company. All right, the next item here is logic apps. So logic apps and functions are similar, that they get triggered when something happens, and then you do work based on that. So logic apps, as you can see here on the right-hand side, it's more of a drag and drop GUI interface. So these things are triggered, again, similar things, blob storage, event hubs, file shares, those sorts of pieces, along with some additional connectors. So things like SharePoint and a Twitter, right? Those sorts of things if you want to set that stuff up. So this is really great for some simple, straightforward integrations or components of that. The one thing that we always warn our clients about is that we should be careful to rely heavily on logic apps, because they're really easy to set up the first time. They're not super easy in some cases, unless you're careful, migrating those between environments and getting all of that set up in a way where you can do things like DevOps and rollbacks and all of that. So I will be showing you one today as an example of this, as a very simple piece, but if you get anything that's a medium to high level complexity, we recommend pulling that out of logic apps and writing that as either an Azure function or a series of Azure functions. Okay, event grid. We've got the next area is event grid. We talked a little bit about this earlier. Essentially, this is the difference between messages, which is service bus, hey, a message with content, and events. Event is, hey, this happened, right? Hey, look, a VM was created, a resource group was created, an alert was created, those sorts of things. So if you have events that you want to react to, again, not messages, event grid is a great situation or a great thing to use there, especially if you are wanting to respond to things that happen inside of Azure. So again, talking about like, hey, a VM was created. Every time a VM is created, I want an email to be sent to somebody. All right, great. Let's hook up to that particular event, have that event sent to event grid, and then we'll react to that on the backside using a logic app or an Azure function. The last of the components in the Azure Integration Services realm is Event Hub. So just like with Service Bus, you have messaging, and Event Grid, you have events. Event Hub is sort of in the middle. Now, event hubs, you can handle messages through that, but they're high scale data. So example we go back to a lot is Internet of Things or like a logging framework. So if you built your own logging framework and you've got a bunch of integrations all dropping messages in, you want to be able to handle that. So we drop that into an event hub, and then on the back end of an event hub, we would hook up probably an Azure function to handle all the messages as they're coming off. So this can handle millions of records a second and be able to scale and handle those appropriately. So if we have a large amount of data, high scale, then we want to make sure we're using an event hub for that to make sure we don't lose anything. So the next thing I'm going to go into is reference architectures. Again, if anybody has any questions over the stuff that we're going through, please jump in and ask the question in the panel there, and I'll be sure to stop. So walking through some of the architectures that we have built for folks, this is an ingest architecture. So think of this as we need to get data into the system and then creates an API on the back end that exposes that data. So we've got Azure functions, again, because they're it's not super straightforward or simple. And we've got different data coming in, FTP, RSS, APIs, whatever type. And we're going to grab all that data and drop it in a data lake. From there, then, in this case, we're going to use an Azure function and transform that data into either relational data or non-relational data into Cosmos. And then we've got another function on the front end acting as essentially an API endpoint to get to that data. So, and then we want to protect that using API management. We want to make sure that we've got things, like I said, rate limiting and authentication and all of that cross-cutting concerns at that point. And then really all the data API is just the business logic of when a request comes in, how do I serve that up? Another architecture that we've built out is a scheduling architecture. So we talked about how the Azure functions have the ability to run on a timer. I want this function to run every 2 minutes, every 3 minutes, every whatever. And that works really well. It's very, very, very stable, very capable framework. However, if you have a lot of integrations and you want to be able to tell which integration is running on which schedule and then easily update that integration to maybe run on an ad hoc perspective or run on a different schedule for a short amount of time, that is hard to manage. So what we've done is we've built a generic scheduler essentially where it runs off a database. We've got a function that wakes up once a minute, checks to see what needs to be run, and when it does need to be run, whatever does need to be run, we're going to use service bus for that. We're going to drop it into a generic service bus queue that's our service bus topic that says this job should be run. And then we've got subscribers on the back end of that, right? One-to-many integrations that do work. So for example, if we need to check for a file once an hour, we're going to put that in the job schedule. That is going to go grab the file. And then when it grabs the file, it's going to drop a message into the job scheduler to say, hey, we've got this item. You know, whatever integration needs to do with this, go do the work. And integration is going to say, oh, that's for me. I can take care of that one, right? And then go ahead and process that data as it needs to. So this is a really nice way of scheduling things if you've got a lot of jobs that need to run on particular schedules that you want better control over. All right, and then the last one that we wanted to talk about is kind of a deeper dive into the file mover. So you can set up a logic app that will check an FTP site and move that file to a certain location on a schedule, like every 3 minutes or something. What we've noticed in that example is it's not super robust. For example, if the logic app happened to be disabled, it's not going to pick anything up after it's been disabled. So if you were to re-enable it, it won't go back and find everything and pull that stuff forward. Logic app fails for some reason, whatever it might be, it's kind of hard to track. So we have built out sort of a deeper, much more fully functional file mover integration for this. So this runs off of our generic job scheduler. You can see how these are all fitting together right into this big engine of this vehicle that we're going to drive down. Essentially says, go move this file. It grabs a file. We've got things integrated with a database and Key Vault for security purposes. And the file mover does its work. And then it leverages, again, Service Bus to say, hey, I've got my file. I've just moved this file. go ahead and do work, right? So maybe there's an accounts receivable process down the stream that needs to do some work when a file comes in. In that case, then that accounts receivable says, oh, I got a file, I got to move it. I'm going to go process it, and it goes off and does its work. So these are three sort of more detailed examples of sort of complex integrations that we've built for folks, and some ideas on how you can leverage some of these components like functions, logic apps, service bus to get all of the information to move across your organization. All right, so with that, I'm going to switch over and give a demo of some of these Azure Integration Services. So let me bring up my content here, 1 second, so I know what I'm doing. All right, so I'm going to switch out and show you here. So I've got a couple of components already built out in Azure, and I'm going to build the rest of them as we go. So I've got a storage account and a service bus namespace. Namely, these take a couple of minutes to build, and they aren't immediate. So what I wanted to do was to get those built a little beforehand so that we weren't wasting time watching Azure, little spinny wheel. So what I'm going to do is I'm going to try to simulate somebody uploading something to blob storage, having a logic app take that file, move that file, drop a message into a service bus queue, and then have a function app respond to that service bus queue and send an email. So pretty straightforward approach there, and I want to show you guys how to build it. So the first thing I'm going to do is in the portal here, I'm going to go and create a new logic app. So logic app. And is everybody seeing my screen now? Everybody seeing the Azure portal? Hoping so anyway. Okay, so I'm going to call it AIS Demo Logic App 01. It's going to be in East US, and I'm going to click Review and Create here just to show how simple these things are to build. All right, fantastic. Just like that, we've got ourselves a logic app. So when you start a brand new empty logic app, you have lots of examples here. I did mention some of these, some of the items that can trigger a logic app. So messages received in the service bus. There's a webhook. If you want to do some work on Twitter, you want to do Outlook.com, FTP server, mention that. For our example, there's no super straightforward one out of the box, so I'm going to go ahead and create a new one. And the first thing I'm going to do is connect to Azure Blob Storage. So my trigger says from Azure Blob Storage when a blob is added or modified. So I'm going to go ahead and do that. I'm going to pick my storage account that's in mine, and I'm going to call this AIS Blob Storage. For my connection, it's going to create that. And now I've got some options on what I want to do. So I've got to tell the logic app which container, or essentially which folder inside of this storage account I want to be watching for. So I'm going to pick upload. And I can, if I want to, I can process up to 10 of these or how many ever I want to at a time. I'm going to leave it at 10. And here is how often do we want this logic app to run and check for a new file. This can be configured in hours, minutes, days, weeks, months, if you want to. For the purposes of this demo, I'm going to go ahead and pick 10 seconds. Seems like a lot, but we just want to make sure that we're getting things there so we can see them come through. So I'm going to save it. That's all I'm going to do for now. If I go back to the logic app, you'll see that I haven't had any runs yet. So I'm going to go ahead and do some work here. So I'm going to go back to my home and sorry, go to the dashboard here and bring up my resource group. So if I go to my resource group here that I was looking at, I'm going to go to this storage account and I'm going to upload a file to simulate somebody uploading a file for this. So I'm going to go to the container and I'm going to go to upload and I'm going to upload an aptly named text file 1. Okay, just a text file, no big deal. I'm going to click upload. Great. You can see it's been uploaded. Now, if I go back to the Logic app here and wait a few seconds, we'll actually see the job run down in the runs history. Aha, there we go. So I want to just dig in and show everybody what you get as part of this. So this is saying when a blob is added or modified, I'm looking in the upload container, and here's the information that we get. I want you to pay attention to a couple of things. One is path and one is name. We'll be using this information as we build out the rest of our Logic app. As you can see, without having to write any code, this is the information that we're receiving. Okay, I'm going to go back to the Logic app and add a few more things in here. Now, once it's been added or modified, what do I want to do? I want to move that file to the archive. So I'm going to make a copy of it. And what's the URL? So I'm connected to my blob storage through my connector, and I'm going to go over here and start typing in trigger body. And this is triggerbody.path. That was the path file. That was the path to that particular file in the payload that we saw. And then my destination, I want this to be archive/triggerbody.name. And that was the name of the file. All right. And we're just going to do overwrite in case I upload the same file twice. So we're going to essentially move from upload to archive. I'm going to save that. Now, it doesn't make any sense for us to continue to leave the file in the upload. So what I'm going to do is delete blob. And my blob to delete here is going to be triggerbody.path. So again, low code, what I'm doing is when a file gets uploaded, I'm going to copy it to a new location and delete it out of the old location. Seems simple enough. Let's go back here and upload another file to our storage account. And this time we will upload test file 2. Okay. Upload it. Great. So if everything goes to plan, we should see test file 2 be removed here shortly. Test file 2 has been removed, and it should be in the archive location. There we go, test file 2. So I'm going to go back to my resource group here and go and take a look at the Logic app. Now our Logic app has a second succeed, and if we go and take a look at the history here, we'll see that it in fact did copy and then delete the blob. So we are in good shape there. If I go back to my Logic app, let's see here. Now, what I want to do is actually take the content of that file and drop it onto a service bus. So I'm going to go back into my Logic App Designer, and I'm going to get a new or add a new step here for storage blob. And in this place, we want to get blob content using the path. And in this case, my path is going to be archive slash trigger body dot name. Okay, so that's where the file went. And I'm going to go ahead and leave that. And then what I want to do is take that information and drop it onto a service bus message. So I'm going to drop it on a service bus queue, sorry. So I'm going to send a message, and I'm going to use my service bus 01 demo. And this is just the security. So I'm going to use the shared access key. I'm going to call this here. So AIS service bus. Click create. So that's going to create a connection from my logic app to my service bus, and it'll automatically give me the queue. So as part of the setup for this, I had a queue called new file, and I'm going to add a parameter, and I'm going to add a content parameter here, which will add the content of the message. And in the content of the message, I am going to go down here and do file content. So this is going to put the file content received from this here into the content property of the message and send it. I'm going to click save, go back to my demo and do another upload. Here. And I'm going to upload test file 3. There we go. All right. And this time I'm going to go back and watch my logic app. There we go. And if I did everything correctly, yay, succeeded. All right. So in this case, I'm going to go and take a look at this execution, and we've got green all the way through. So we deleted it. We grabbed the content, which you can see is this is a test file 3. And then we sent a message and we put that on there. You'll see this is just base 64 encoded. So if we went to a base 64 code decoder and decoded it, would show this here. So we've got a message. So we've essentially at this point, we've received a file. We have taken the file, moved it to archive, and then we have sent a message to service bus so that some other application can pick it up and do something with it. So if I go to my service bus and look at the queue that I had created in my new file, we will see 2 messages sitting there. So that was one left over from last time when I was doing this last night. So I'm going to go ahead and delete these 2 because I want to do an end-to-end yes. So receiving, I just received that. I'm going to go ahead and receive another one. And if we look here, you'll see this says this is a test file 3. So I've cleared out the queue. You can see that I did a destructive receive. That was me guaranteeing that only this message is only going to be delivered one time. So let me go back to the demo here. And what I'm going to do next is to actually create an Azure function that will subscribe to that service bus queue. So I'm in Visual Studio now. Go and create a new project. And I've got my Azure function. Click next. And so I'm going to AIS demo function 02. And we will go ahead and create that. Now, because this is a function and Visual Studio gives us some options on how we want to initiate this function. Just like with the Logic app, we wanted to initiate it from a blob storage file getting uploaded. In this case, we've got this nice out-of-the-box one for service bus queue trigger. So I need to set a few settings. One is, what is the name of my setting to connect to the service bus? So I'll call this service bus queue, service bus connection. And then the queue name was called new file. That's what we saw when we were looking in the service bus namespace in the queues. So we've got a new file. So if I click create, so create the code for us. While we're waiting for that, I'm going to go back to my shared access policies here and grab this connection string because I'm going to need it for some of the setup that we need to do. Visual Studio is particularly slow today. There we go. Okay, so let's take a look at what we've got here, and I'll try to zoom in if we can. Pretty straightforward. We've got a service bus trigger, which is going to trigger on the new file queue, and the connection is service bus connection. Let me close that down. So I need to go to my settings, and what I need to do is add that. I'm going to do here, oops, and do service bus connection. And that is this value that I had just saved off from the portal. So function one, I'm going to make sure I name that correctly and I didn't fat finger anything. Service bus connection. All right, great. So this is all good. This will fire off when something is received in the queue, but we're really not doing anything in this case. So I've already got a little bit of code all set up here that will do a little bit of extra work for us. So essentially, I still want to do that. I still want to, oops, but I'm going to do this. I want to send an email with that item. And let me go grab this code. That is really easy to do that. So I'm using SendGrid for this. This is a really easy way of sending email through Azure. Azure doesn't have a SFTP service, but SendGrid is what we'll use for that. There's a little bit of just basically signing up for a free account and getting some information. So for example, there's an API key here, and then the actual data for the API key that you'll need in order to set this up. But otherwise, the code is exactly the same as if you were just using a regular SMTP to send emails. So I am having to resolve just a couple of namespace issues here as things are still getting built. I need to add these two to the top. Oops. That does it. And the build is just going right now. While that's coming up, one of the things I did want to show here was this on this logic app. You can see that when I'm editing it, it's a graphical user interface that we talked about. However, there is a whole code view that if you are familiar with it or you need to really see what's happening behind the scenes, you can dig in and look at the actual code that's running behind the scenes. This is actually something that can be used to check in, similar to what you would check in if you just had C# code or something else. So you can do DevOps and those sorts of things using logic apps. It just is a slightly different approach to doing that. All right, so we're still building. Let's see here. Oops. Not sure what's going on with the build. Cancel and start this over again. Maybe it's angry about that. All right, let me log in here. All right, let's try this again. Demo gremlins. All right, I am going to flip over to another example that I had already built for this and give you an example or show you how this is really going to work if we were to not have to wait for Visual Studio to finish compiling. So I have another whole demo environment I set up that did this exact same thing. You can see here we've got the function deployed out, running the code, the same exact code that you saw. We've got a logic app here, got a storage account. So I'm going to go ahead and upload a file to the storage account here. That way we don't have to wait for Visual Studio. Do this file. All right, so in the upload file 10. So same exact thing should happen. We just finished the upload. If I refresh here, go back to my logic app here, wait for it to succeed. There we go. We just ran that. So if we go back to our storage account, we'll see that the data was moved to the archive. There we go, we've got test file 10. And I've also got an inbox here set up that will eventually show the email when it comes through. Now this is going through SendGrid and all the other pieces, so it does take a minute for the email to show up here, but it will show up. One thing I did want to show here, one final demo component here, kind of a neat part of functions. If you do go into the functions here, we've got an aptly named function 1. Should be able to see that this thing did actually run. Yeah, it takes about 5 minutes or so for that to show up. So at any rate, we'll get an email there. There it is, new file received. Boom, perfect. So there we go. We just demoed sort of an end-to-end, really quick and dirty AIS demo. Again, we had a text file uploaded to blob storage. And then from there, a logic app took over, did its work, moved the message into service bus. The function app then fired up and took that and sent an email via SendGrid. So you can imagine the possibilities here. This function app can do really anything that you can do with code, including, processing data or notifying other people, right? Running business logic on things and that sort of thing. So that's it. That's the end of the presentation I had for today. I don't see any questions in the question bar right now. Does anybody have any questions that they'd like me to answer?
I see you have a few in here, Nick.
Oh, okay. Geez, sorry, I must not be. I must have missed those. Can you maybe recite those to me?
Yeah, absolutely. Let me know if you've already touched on them, and then we'll keep moving on.
Sure.
Says a question that comes up a lot is around the cost for service in your example. Could you touch on how billing cost could work?
Sure. So I think likely if we go back and talk about, let's go back and just pull up a simple integration. So something like this, if you had to figure out what is this going to cost, right? In this case, you could handle the SQL database pretty easily on a basic tier. So we're talking, a few bucks a month, maybe a little bit more. On these execution part, again, most of these executions are taking less than a second. So if you had a large number of integrations and you were running 100 an hour every minute, I mean, you're still thinking of paying still dollars, right, for running this per month. The things that get a little more expensive is API management. So that is, you pay for kind of service tiers on that. There is a consumption-based model for API management, so per execution. But most of the time when you get into a production environment, you want to move up to like a standard or even a premium level of that. Standard level, I believe, is a few $100s a month. Premium is pretty expensive. but you get a lot of cool features with it. So we always start at the standard and then move to the premium if we need to. So internal VNet integration and some more customized authentication and that sort of piece. And then Service Bus, you pay for the messages that go in and out of there. But again, it's pretty cheap. I don't have a calculator up here, but I mean, if you spent $100 a month on the Service Bus queue, you'd be pushing a lot of data. So again, it's much cheaper than if you were to spin up virtual machines and try to handle all of this yourself through code. This is going to be a lot cheaper, and it's going to flex based on demand. So if your demand goes down for a month, right, you're going to be safe there. You won't be spending that sort of consistent amount of money. You should drop quite a bit as you drop. What was the next question, Crystal?
The next question you had is, can we make changes in code behind of Logic Apps?
So you can sort of make changes. So if I go back to my Logic app here and take a look at this. So if I needed to change, for example, where I was getting information, right? So instead of sending the message, I wanted to do a different calculation, for example, and what the content is, you can do that. There are also things in here for like setting of variables. There are also things like conditionals and for eaches and scope. So typical things you'd see in development, you know, hey, give me an array of items, and for each of those items, do that thing. You can do all of that inside of Logic Apps. Now, can you functionally change the way that the, for example, how the delete blob works? No, that just works the way that it works. So you can kind of tweak things, and I've seen some pretty crazy calculations on, you know, down in the expressions using things like, you know, text contains, length, you know, all of these things. So your formulas can get pretty complex, much like an Excel formula can get pretty complex, but you can't intrinsically change what, for example, the delete blob does. You either use it or you don't. All right, Crystal, what's the next one?
The next one is, what again replaces SMTP service for emails in Azure?
It's called SendGrid. That's what we use. That's a paid service. So there's no like, so you basically have a contract and agreement outside of Azure for SendGrid, but it integrates really nicely. You can actually buy SendGrid inside of Azure if you wanted to. So that's what we recommend. You can do things like Office 365. There's a way to connect there. There's a way to write custom code using the Graph API to do that, to send emails that way. But the most seamless way of doing it, if you're familiar with SMTP stuff, is just to use a SendGrid account.
Awesome. The next question is, can Logic Apps be used to trigger an ADF pipeline, ingest data from a file once it's landed in a SFTP site?
So the way that I would potentially wire that up, so a Logic app can be triggered to check for SFTP files and move and do things when that happens. So if there is like some sort of webhook capability or other piece of integration, that's what I would use a Logic app for. So the Logic app would wake up when a file was dropped, right? And then again, call like a webhook or something like that. I'm not super familiar with that particular piece of technology, so I don't exactly know what the capabilities there are, but think of it as waking up and then connecting using either messaging or HTTP or something like that.
All right, the next question is, I think we're getting to the bottom here. Any comments on cost? How make sure don't spend too much? How to make sure you don't spend too much?
Sure. Yep. Yeah. Fair enough. So you have to be careful, right? When you're scaling these things. So the nice part is that they can scale infinitely, right? Not really infinitely, but they can really scale. The bad news is they can scale infinitely. So when you are creating things like, your functions and logic apps, there are ways of basically saying scale, but don't infinitely scale. So here's the max number of workers I want to have. Here's the max number of items that I want to have consumed. So if that is a concern, that you don't want some runaway process, right? Like consuming all of that, you can set those things up. In general, though, the idea of making sure that the costs don't run away, there's a whole governance structure and thought process that you have to go through when you're essentially implementing Azure, right? Whether that be Azure Integration Services or anything else. And each company is different, and you need to be able to find that nice mix between basically not allowing anybody to do anything without 25 levels of approval, right? And giving folks like myself, like it's the wild, wild west, ability to create any type of resource you want. So there are ways of doing that through security groups, and there are ways of doing that through Azure policy. So for example, I can't spin up on M128, which is the biggest VM, right? One of the biggest VMs. I can't buy an M128 because that's going to cost 20 grand a day, right? Like those are the sorts of things you can do. So we do a lot of that when we're setting up our Azure environments for our clients. We have a whole section just around governance to make sure that people can do what they can do, but people can't do what they shouldn't be able to do.
All right, let's see. We got a couple more here, and then I think that's about it. Oh, we got one more. How different is SSIS? Okay, two more. How different is SSIS development in Azure?
So SSIS development in Azure, there are a couple of ways. I'm not super well versed in the SSIS stuff, but I've done a little bit. So you can basically set up like an SSIS integrated environment in Azure. You're basically setting up compute, so VMs to do that work for you. You can set that whole piece up and kind of just migrate the SSIS stuff over. You can also use managed instances, I believe handle SSIS. Could be wrong there, but essentially managed instance of SQL is like the middle ground between a virtual machine running SQL Server and Azure SQL, which is you don't have any access to the servers at all in that area. So you can do that. A lot of times, though, if you're going to do things cloud native, we'll see people use Data Factory. So Data Factory is a great approach to sort of do a cloud modern approach. So Data Factory and Azure Functions, you pull the code out of your SSIS packages and run them differently using those cloud tools instead of using more sort of on-premise SSIS capabilities.
All right, that looks like that was the last question. So I do see a question in here that asks if you guys will get the recording. Yes, you will receive the recording tomorrow in your email box around noon Eastern Standard Time. So look out for that. Also, if you want to preview any of our previous webinars, you can check those out on our YouTube channel under free webinar. I want to thank you, Nick, so much for coming in and hosting. Thank everyone for attending. We appreciate it, and we hope to see you guys in the next webinar on Tuesday. And like I said before, if you guys want to download Nick's slides, please feel free to do so in the handout section of the panel on the side. Thank you guys again, and I hope you guys have a good rest of your Tuesday.
Thanks all. Bye.